Okay, printed circuit board design and layout with KiCAD. KiCAD? KiCAD.
Actually, I watched a video from France, and they call it KiCAD.
KiCAD.
Since it was originated there, I guess they got it right.
Yeah, but that's the French. And
KiCAD.
okay.
Well, it's called KiCAD.
Does everyone know what a printed circuit board is? No one know? Okay. So I've been building circuit boards for many years, and I've never used this particular program. I used several others with varying success, and then Eddie told me to try this, so I did. And it's open source. It's got a large support group. There are multiple programs linked together by a GUI. That's good and bad. I've noticed that the user interface isn't completely consistent between the programs, but it's not too bad.
The advantage is that they are allowed to operate or progress at their own rate. You're not looking for one complete revision level for a completely closed system.
Right.
So, for example, recently CERN has added a shell router to the program suite. And if it was a monolithic kind of thing, it would have been really difficult to get that included.
The design files are in ASCII text, so if you want to do some global search and replace to fix some things that you didn't quite understand how things worked, and you have a whole bunch of work into the project, it's actually easy to go do a global fix.
And you say it's ASCII text, and then it's vaguely comprehensible for a human to read?
It is very comprehensive.
Yes.
Okay.
It only takes a few minutes to figure out what elements are doing and how they're manipulated. It took me less than 5 minutes the first time I looked at it, and I'm like, oh, I can read this.
Good deal.
And the other thing is you're much less immune to database corruption. So if you have one of these monolithic database type structures and you get a write error or something in it, the chances of you going in and fixing it, slim and none.
Yeah.
With a text-based database, it's very easy to go in and go like, yep, here's the problem. I can salvage from here up or from here down.
All right.
The library set is really large. There's been a number of people working on it, and they've made tools just to incorporate library elements to make it easier for you to add new elements. And recently, I've seen some database entries that say that they can convert like eagle symbols into KiCAD.
Nice.
The 3D viewer is a really nice feature. If you lay things out on, I'll show you all of this later, but you can lay things out on a board, and with the 3D viewer you can get a real feel for where things are and how they're going to fit before you ever send the boards off to be built.
And there's a export thing to get a DXF out of it, I think.
Yes. Okay, so there's a central project manager. There's a schematic capture editor. You can design your own footprints. You can design the components for the schematic and also the footprints for the circuit board. You can produce the Gerber files, which are used commonly used to send off to a company to manufacture the boards. Documentation's online. The electrical rules check, that's something I haven't used yet because I'm still learning the program and I haven't got things set up quite right, so I fail a lot of the rules checking. The schematic program will export a net list. That's a list of all of the interconnections in your design, and that is the list that's imported into the printed circuit board program to guide you in connecting the different pins of the components. There's a bill of materials that I haven't used yet in the integrated libraries. I just started using this program a few weeks ago, and I've already sent an order out to have boards made, and I have the order here, so I'll show you guys some boards that were made using this. There's a manual router, interactive routing. I have not tried the auto router.
The auto router is a little bit different than most people would think. You basically package it up, send it off to a cloud engine. It'll auto route it based on your parameters and then send it back.
Is that no cost?
Correct.
The footprint editor I made extensive use of because a lot of the components I was using didn't have a footprint. And it's pretty intuitive, and I managed to make a couple of fairly complex footprints. And the design rule checker is a lifesaver because it finds all of the screw-ups, or at least most of them. At least the board I designed worked.
So you mentioned something earlier, that there was a very large parts library, so the footprint library is not as large as well, or is it still?
It is very large, but there's literally hundreds of thousands of different components. It is hard to find every component you'll ever use. So you'll usually end up making some parts. For myself, I've been using it multiple years, and I generally either take a part out of the library and make it sure that it fits my application, meaning that the parts that I picked for the bill of material, I verify every spec, and I put it in a separate library just for that part, or just for that board.
So I've always found the limiting factor in the CAD program, the PCBs, is the footprint. Always have to make
Absolutely.
footprints.
If you're going to do PCB work, you have to accept the idea that you're going to make your own footprints.
Darn, I thought this was-
It's a pretty easy tool to make the footprints. I mean, I could do it.
There's wizards that'll also help you on doing this. But one of the key features of this that you can gloss over if you don't notice it, is you can find the footprint in the schematic and pick it up in the PC board layout. Or, for example, a lot of parts you can get them in pin and hole, SOIC, TSOP. You can select whichever footprint that you want at the time of building the board, and you don't have to worry about it at the schematic phase. So you can use the same schematic for a prototype for pin and hole, and then build a surface mount board after you've done the prototype.
I have no experience with bill of material.
So I've found recently 2 tools for bill of material. In the most recent version of KiCAD, took away a lot of the options on doing the bill of material and create a schematic XML file, which is basically just a list of all the components and all the attributes for each of the components. Now, there's been at least a dozen different attempts to make really useful tools for creating bill of material. The 2 best that I've found so far is Bombs Away, which allows you to edit the schematic and add all the attributes you'd like to add. For instance, manufacturer's part number, supplier part number, link to the database or to the data sheet. And it's an external GUI program that you pull in the schematic, you edit all these things based on the size of the component, the footprint of the component. And then it stores it back into the schematic, so you have it permanently back in the schematic. The second is key cost, and that allows you to build a spreadsheet that's submittable to like DigiKey or Mouser to order your parts or get an estimate of your parts. And from those tools online, you can get like quantity pricing and stuff. So it makes it much easier to order the parts that way.
There's a lot of stuff online.
If you go to the KiCAD website, there's an example page, and they have just dozens of examples of people who made boards, processor boards, or what have you. I looked for some large boards, but really didn't see any. The second link here is the CERN has gotten involved and built the shove router for KiCAD, and that allows you to be less stringent when you do your initial routing, because if you have to work in another trace, you can put it in shove mode and then just start wiring it. It'll push everything else you already put in place out of the way as you route the last wires. Really slick. Personally, I've never really used the auto router successfully. I like doing things manually. I've been in the industry for 30 years, and auto routers sound really good in principle, but unless you're an expert in defining the parameters for it, it's really useless. Things like memory boards, where you have consistent LAN patterns that you use over and over, auto routers work really well on. But things like processor boards or anything that's complicated like bit bulk arrays or pin arrays, it doesn't do very good jobs. And there's just tons of online tutorials. If you look at YouTube or just look up KiCAD tutorials, you'll get 50,000 hits.
And that's it for the slideshow.
So, how many layers?
I think 32 layers is the amount. There's no board size restrictions like Eagle has a board size restriction of 100 by 80 millimeters, I think, and 2 layers. You can do 32 layers, and if you can figure out how to get the size in there, I think you're, 32,000 mils or something is what your word size is limited to. Yes, sir.
Well, what's the general cost then to get a board fabricated once you've generated it?
Okay,
Depends on the size of the board,
Of course, yeah.
number of holes.
I'll be able to answer that in the next presentation.
Great, okay.
This was just to tell you that Eddie and I are, if there's interest, we'll teach a class on how to use this software. Okay.
So go on
So-
Facebook and to the poll.
Right.
Where's the poll at?
Gainesville Hackerspace.
Gainesville Hackerspace
Not
Facebook group.
necessarily everyone here has Facebook, so we might want to
Well,
do
get Facebook just for Hackerspace.
Okay. So last month, I demoed this little device that I had built. This is the ESP8266 Wi-Fi chip, and this is a completely hand-wired board, and I had it hooked up to these relays and showed you all the web page where you could connect with your phone and turn the relays on and off, and actually it's online again. And if you take your phone and go to 192.168.200.178, you can see the relays there. Turning on and off. Okay, so I took the design that I showed you all last month, and I used some software, not KiCAD, and designed a board, and I really wasn't happy with how it came out. But it sort of worked. But it was expensive and slow, and this is the board, and there's no silk screen and no solder mask, but it worked. Then Eddie told me about KiCAD. And I started from scratch. Here's the program, and you can, let's see here, this is an older design, but it'll work. We can open up the schematic. So you design your circuit, you do the schematic design, you associate footprints and create a net list. And then you make a printed circuit board. I've got a bunch here. And this is not the current one again, but there's this. Can you all see that?
Take the view into standards instead of OpenGL.
Is that better? So you can see the front copper and the back copper. You can turn layers on and off. You can move things around, just drag and drop. Then you can run the wires. You can see the conductors running between pads. Move things around. It's a very simple, intuitive tool. It's got a lot of flexibility. So I designed a new board, and here, pass those around. So I expanded on my original design. I made this more of a development system board. There's a voltage regulator mounts on the back that can take an input up to 50 volts to give me 3.3 volts to run everything else on the board. I have an analog input, so I can measure an outside voltage up to 50 volts and use that outside voltage that I'm measuring to run the device. I've got obviously digital outputs because we're controlling relays here. I have digital inputs. This is one of the boards that I've passed around already assembled. Voltage regulator on the back. It's got voltage divider to divide 50 volts down to 0 to 1 volt for the analog input.
Wi-Fi board then, right?
This is a Wi-Fi board, yeah. Well, the chip, the main chip that solders on the front is the ESP8266 Wi-Fi chip.
Does that come with a web server in there?
No, but there's a lot of software online for that chip.
It's available for the chip?
Yeah, there's a lot of people developing for the chip. It's really inexpensive. It's a couple of bucks on eBay. If you order them in a larger quantity, you can get them down under $2. These boards, I did the design in KiCAD. I sent the order out on Wednesday, and they came in yesterday.
Where did you send it?
China.
And what was the cost? I missed that.
It was about $47 for 42 boards. A little more than $1 a board. That was including the shipping. Right.
You send the order out by way of email, I guess.
Yeah, I uploaded the Gerber the Gerber files to the site. We went back and forth a few times before we got all of the communications issues worked out. But,
Is this credit card sort of a thing, payment?
PayPal.
PayPal.
The first one was domestic. I got 3 boards without silk screen or solder mask for $61 plus shipping.
That was 41.
You're right, it was $41 plus shipping. It was about $65, $67 with the shipping. This was 40 something, 40, I forget the exact price, I can look it up. With shipping for, of course, they're smaller boards.
They have predetermined sizes that they give you bargain.
Nope. Nope. And you need to work with them. I went back and forth, as I said, a few times. At first, I laid these out in a 4x4 pallet for a 100 centimeter square board, and they were asking me things. Well, don't you want V-cuts, or how do you want them separated? And I said, well, what would be the price if you just made them 50 centimeters squared? And it was cheaper.
You were thinking you were,
Right, I was thinking I was saving money, but
You save $4 by getting individual boards.
yeah, the price came down $4.50 when I had them cut the boards.
And what is the name of this company?
This was, this group is called All PCB, and All ALL PCB.
And they front for about a dozen different.
Right. They send your design out to a bunch of different companies, and they come up with a price.
That's like allpcb.com sort of a thing?
Yes.
Perfect. Thank you.
So if you're gonna do a class, maybe you explain how these sorts of things work?
Yeah, we'll probably have a design already made, and we'll recreate the design that we already have in the class, and maybe send them out, and everyone will get boards.
Cool.
So the intent of the class is to teach you how to use KiCAD. We may, like Joe says, have an example so that you walk away with something. We'll send out a set of boards and have them built, and everybody will have some printed.
Is there a possibility of doing a preceding class teaching some of the electronics principles?
Sure.
Corresponding to the board?
If there's a
Sure.
desire for it. What I'd like to do is a continuing class from month to month, where if you have a project, come to the class. There'll be a lecture for everybody, but then you can work on your individual project.
Cool.
Something else I forgot about this, but this is my most recent circuit board design. I've been doing circuit board design, different types, printed circuit boards and other types for years. And I happen to have with me the first circuit board I ever made. And it's right here. And all the chips are gone, but it's a wire wrap CDP 1802 Cosmac ELF from the 1975 Popular Electronics article. And I built this while I was on board the USS Chicago, those long nights at sea with nothing to do, and so from that to this.
Now, how did DPS get the parts to you?
What's that?
How did DPS get the parts to you?
Oh, no, I went up to these electronic stores in Claremont Mesa, north of San Diego, and spent my paltry sailor's salary to buy stuff.
That seems easier.
This is not that different. This is not that different from what I did last month. Okay? This is the prototype that I built last month, and this was a prototype. Although this never got distilled down to that. Yes.
So, I don't know the sorts of things that you can do with this. Why did you build 42 of these?
I actually have a use for these. In the business that I have that pays the bills rather than plays, I have clients that have me build like solar-powered microwave relay stations that sit out in the desert or on mountaintops or out at a blueberry farm. And I needed a way to monitor the solar panels and the battery, state of charge of the battery. So this is designed with the idea that I can hook a 12 volt or 24 volt or 36 volt battery pack directly to the input, and it will record the battery voltage, report it back to a Raspberry Pi that's located on site. The Raspberry Pi is tunneled back into my office, and all of the data being gathered at my various clients' remote sites is stored on my server at my office. So I can get alerts if a battery voltage or it drops too low or whatever I want to program it to do. Depends on how much interest there is. He's the expert on this software. I just learned this stuff. A month ago when I did this first board, I didn't know anything about it. I was using Protel. I didn't like it. It's a real pain in the ass to work with. So I went with this other company, and because they have their own online software, which was really easy to use, but somewhat limited, and you're tied to them. You can't order boards from anyone else. Yes?
Do you think that this class will make its way to talking about the techniques for 100 megahertz, 200 megahertz, 300 megahertz on board?
That would be this man's expertise.
Get that far?
Probably not the first class,
Well, sure, yeah.
but
Maybe,
if we can get enough interest and continue it on, anything's possible.
Oh,
I've done multi-gigahertz boards.
I was talking about the 3D viewer.
Few nuances beyond just layout that you have to look at, like the length of the board.
So here's the 3D view of this board, and you can see the spacing of the components and how things are going to look, or get an idea what things are going to be like on the finished product.
For your main chip there, did you solder that by hand, or do you have some sort of reflow of it?
This, as I said, these boards just came in yesterday,
Okay.
and yeah, I assembled this by hand.
Can you order them pre-assembled?
All PCB doesn't offer that service, but there are other companies that offer that service.